This is second day of 9-2, and we're going to do roses today. Now, this coefficient of theta determines how this rose looks, along with 6, but 6 is just the length of the petal. So let's start with the fact that that coefficient is even. When this is even, we're going to have to graph from 0 to 2 pi. We're going to count by pi over 4s. We're always going to double this coefficient to find out what the denominator is of what we're going to count by. So 0 to pi, they're going to be 4 petals. 4 petals, and we always double this number to find out how many petals we're going to have when this coefficient is even. So let's count from 0 to 2 pi. I'm going to go with pi over 4. So 0, 1/4. 2/4 would be pi over 2. 3/4, 4/4. 5/4, 6/4 is 3 pi over 2. 7/4, and then 8/4 is 2 pi. Now there's good news with this. That when you count by pi over 4s, when you do the process of doubling the coefficient, counting by pi over 4s, there's a pattern that emerges. Let's plug in a few of the points to start out with. We're going to plug 0 in. Cosine of 0 is 1, so 1 times 6 is 6. When we plug pi over 4 in, multiply that by 2, we get pi over 2. Cosine of pi over 2 is 0. So we get 0. Excuse me. So now here's the pattern. Well, let's do one more. Cosine of, when we plug pi over 2 in, we get cosine of pi, which is -1, which is -6. Now you can plug in the rest if you want, but the pattern is going to go 0, and then 6, and then 0, and then -6, and then 0, and then 6. It alternates zeros, and then alternates 6, negative, positive, negative, positive, when you count by pi over 4s, when you use the process that I've given. So now let's plot these points. 0 radians, 1, 2, 3, 4, 5, 6. And then pi over 4, when we get to pi over 4, we're back to the pole. Now, you just have to know that if we graphed a bunch of points, it would look something like that. It's going to be half a petal. Pi over 2 is -6. 1, 2, 3, 4, 5, 6 down here. And then so it's going to loop around like this. 3 pi over 4, which is over here, is going to be 0. So then it loops like this. Pi is 1, 2, 3, 4, 5, 6. Loops around like that. 5 pi over 4 down here, we're back to 0. So back to 0. 3 pi over 2 is up at 1, 2, 3, 4, 5, 6 up here. It's going to loop around something like that. Well, that should be a little more curved. It's a little too sharp up there. 7 pi over 4 down here is back to 0. And then when we get to 2 pi, we're back to 6, and it finishes the 4 petals. It's a decent graph, decent version of what it should look like. Can I minimize this? Is it letting me? Wish I could switch over. Yeah, I'll try that. That's what it should look like. Very, very nice version of it. All right, how about the next one? Now we're going to look at odd. So 3. So we have an odd coefficient there. Odd, we only have to graph from 0 to pi. So when we have an odd, we graph from 0 to odd, 1 pi. When it's even, we graph from 0 to even, or 0 to 2 pi. That's one way to think of it. Hopefully that helps you remember. All right, 0 to pi, we're going to count by pi over 6s. Pi over 6, we're going to double that coefficient, and there will be 3 petals. So when this is odd, there's the same amount, 3 petals. When the coefficient is even, we double that. There ends up being 4 petals. So we have an idea of how this is going to look before we even graph it. So we count by pi over 6s, but we only have to go to pi. 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. But now remember, there's going to be a pattern here. When I plug 0 in, cosine of 0 is 1, so that's 4. When I plug pi over 6 in, that's pi over 2. Cosine of pi over 2 is 0. So then it goes -4, 0, 4, 0, -4. So positive, negative, positive, negative, 0, 0, 0. So 0, 1, 2, 3, 4. Pi over 6, which is right here, is already to 0. So to there. Pi over 3, that's actually here is -4. So back here, 1, 2, 3, 4. Pi over 2, back to 0. 2 pi over 3, that's up here, is 4. 1, 2, 3, 4. Like that, it's going to loop around. 5 pi over 6, that is actually right there. That's back to 0. And then pi going this way is -4, so back the other way. So let's get a nice version of that. There it is, right there. Here's the next one. We're going to do the same thing, except instead of cosine, we're going to look at, well, what does sine look like? So notice that with cosine, the pedal starts on the x-axis. So right here, down here, when we have cosine, the pedal starts on the x-axis. Well, when we have sine, that's not going to happen because at 0, sine of 0 is 0. That pedal's not going to start on that x-axis. So let's take a look. This is odd, so we have to count by pi over 6s, but only go from 0 to pi. Count by pi over 6s. All right. 0, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. Sine of 0 is 0. When we plug pi over 6, we get pi over 2. Sine of pi over 2 is 1, so that's 7. Then it goes 0, -7, 0, 7, 0. So 0, 0, 0, 0, every other one, and then 7, -7, 7. 0 is 0, so we're at the pole. Pi over 6 is 7. So from 0 to pi over 6, we have half a pedal. Pi over 3 is up here, and we're back to 0. Notice this pedal did not start on the x-axis. It's shifted over. It's rounded, it's over by pi over 6. See, pi over 2 is -7, so pi over 2 is down here at -7. So that loops around. 2 pi over 3, which is here, that's back to 0. 5 pi over 6 is 7. That's up here. So it loops half a pedal there. And then pi is back to 0. And we're back to the beginning. There's a nice version of it. Very symmetric. Went to Desmos and graphed this. And then here's our last one. Sine with even. We have to graph from 0 to 2 pi, and we have to graph by pi over 4s. We're going to double that coefficient. 0, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4. So 0. Plug 0 in, sine of 0 is 0, so that's 0. Pi over 2, when we plug pi over 4 in, we get pi over 2. Sine of pi over 2 is 1, so that's 6, 0, -6, 0, 6, 0, -6, 0. So positive, negative, and every other one is 0. So 0, 0, notice it's not going to start on the x-axis, the pedal. The pedal's going to be in the first quadrant. Pi over 4 is 6. Pi over 4, 1, 2, 3, 4, 5, 6, right there. So we have half a pedal. Pi over 2, back to 0. 3 pi over 4, that's over here, is -6. That's down there. So there's the next pedal we're going to draw. pi is back to 0. 5 pi over 4, that's right there, is 6. So here's going to be the third petal that we draw. 3 pi over 2 is 0. 7 pi over 4, that's down here, but we're going negative 6. 1, 2, 3, 4, 5, 6. So we're going to draw the petal now in the second quadrant. And then 2 pi, we're back to 0. Here's the Desmos version of that graph right there. Very symmetric, very rounded, and the length of the petals are all 6.